Hello, everyone. Welcome back to Tech Teacher Shruti. If you're just starting your Java programming journey, you're in the right place. In today's video, we're going to learn one of the most important concepts in object-oriented programming, Java class. Have you ever wondered how Java represents real-world objects like a student, a car, or a bank account? The answer is through classes and objects. A class acts as a blueprint, while objects are the real entities created from that blueprint. By the end of this video, you'll understand what a Java class is, why classes are needed, how to create your first Java class, how to create objects, how to access variables and methods using objects, and finally, why classes are so important in Java programming. So, if you're ready to learn Java in an easy and practical way, let's get started. Imagine a college has 10,000 students. Every student has name, roll number, branch, age. Can we create separate variables for every student? Student 1 name, student 2 name, student 1,000 name? Impossible. It becomes difficult to manage. We need a better solution. That solution is class. A class is a blueprint or template used to create objects. It defines data, variables, behavior, methods. Suppose we want to store student details. A student has name, age, roll number. These are data. A student can also study, attend class, write exam. These are behaviors. Java stores both inside a class. A class is only a design. Objects are the actual things. An architect draws a layout detailing where the kitchen, bedrooms, and doors go. However, you cannot eat, sleep, or live inside a piece of paper. It is just a specification, a design, or a template. To live in it, workers must take that blueprint and physically build a house. The resulting structure is a physical, concrete instance of that blueprint. The Java class, the design. The code block defines a class house. Just like the blueprint, writing this code doesn't actually create anything in the computer's memory yet. It just describes what a house should have. Attributes, fields, means state. Rooms, doors, windows, etc. These match the blueprint specifications. Methods means behaviors. Display details. What the house can do or how we interact with it. The Java objects are the real things. To actually use this design in a program, you must create an object, also called an instance. In Java, this is done using the new keyword. For example, house1 equals new house. When you do this, the computer allocates actual memory for house 1, house 2, and house 3. The bottom section highlights the most powerful aspect of OOP, which is reusability. You only need to draw a blueprint once, but you can use it to build an entire neighborhood of houses. Similarly, you only write a Java class once, but you can use it to create hundreds of individual objects. Each object, house 1, house 2, and house 3, follows the exact same structure defined by the class, but they can have different individual traits. For instance, house 1 might have 3 rooms and a blue roof, while house 2 has 4 rooms and a green roof. There are 3 distinct sections from top to bottom in the image. First, the class name, student. This is the name of the class. In Java, this tells you that you are creating a template meant to represent a student entity. Second, attributes, fields. This section defines the state or data that every individual student object will hold. ID, a unique identifier for the student, typically an int or string in Java. Name, the student's name, typically a string. Age, the student's age, typically an int. Third, methods, behaviors. This section defines the actions or behaviors that a student object can perform. Study-O, a function that defines what happens when a student studies. Display-O, a function used to print out or showcase the student's details, like their name and ID. This diagram explains how to create and use an object in Java. So far, we have learned that a class is just a blueprint. A blueprint only describes what an object should look like. To actually use that blueprint, we need to create an object. Let's understand this step by step. Student, this is the class name. S1, this is the object, reference variable. New, this keyword creates a new object in memory. Student parentheses calls the constructor and allocates memory for the object. The student class is the blueprint. Student S1 equals new student creates a new object. The object is stored in heap memory. S1 is a reference variable. It doesn't contain the actual object. It stores the address, reference of the object in memory. After assigning values, the object looks like this. ID equals 101, name equals Rahul. When display is called, it reads these values from the object and prints them to the console. Imagine a student admission form. The form design is the student class. When Rahul fills out one form, roll number equals 101, name equals Rahul. That filled form is an object. Another student, Priya, fills another form. Roll number equals 102, name equals Priya. Both forms follow the same format, class, but contain different data, objects. Advantages of Java classes. 1. Code reusability. A class is created only once, but we can create many objects from it. This means we don't need to write the same code again and again. Real-life example. Think of a cake mold. You buy one mold, but you can bake hundreds of cakes using it. Class equals cake mold. Objects equals cakes. 2. Better organization. Explanation. Classes help organize large programs into smaller, meaningful parts. Instead of writing everything in one file, we divide the program into different classes. Example. A college management system may have student class, teacher class, course class, library class. Each class performs its own task. Real-life example. Imagine a school. There are separate departments for admissions, accounts, library, examination. Each department has its own responsibility. Similarly, classes organize programs into different sections. 3. Easy maintenance. Explanation. If you need to make changes, you only modify the class once. All objects automatically use the updated version. Real-life example. If a company updates the design of a mobile phone, all newly manufactured phones follow the new design automatically. 4. Modularity. A large program is divided into smaller independent modules, classes. Each module performs one specific task. Example. In an online shopping application, customer class, product class, cart class, payment class, order class. Each class works independently. If one module changes, the others are mostly unaffected. Real-life example. A car consists of many parts: engine, brakes, wheels, steering, battery. Each part has its own function. Together, they make the complete car. Similarly, many classes work together to build one application. 6. Supports object-oriented programming, Java. Java is an object-oriented programming, OOP language. Classes are the foundation of OOP. Without classes, we cannot create objects or use key OOP features. Classes enable concepts like encapsulation, inheritance, polymorphism, abstraction. These features help build secure, reusable, and scalable applications.
Now that we know what a class is and how to create an object, let's understand a complete Java program. We'll explain it line by line. Here, we are creating a class named Student. Think of a class as a blueprint or template. This blueprint tells Java what information a student should have and what actions a student can perform. Opening curly brace tells Java that everything inside belongs to the student class. Int ID variable stores the student's ID. Each student can have a different ID like 101, 102, 103. String name variable stores the student's name like Rahul, Priya, Sita. So far, our class contains student, ID, name. These variables are called fields or instance variables because every object gets its own copy. Void display. This is a method. A method defines what an object can do. Here, the object can display its information. Opening brace. Everything inside this block belongs to the display method. System.out.println ID. This statement prints the student's ID on the screen. System.out.println name. This statement prints the student's name. Closing brace. This marks the end of the display method. Public static void main, string args. This is the main method. Every Java program starts execution from here. Think of it as the entry point of the program. Whenever we run the program, Java first looks for the main method. Create an object. Student S1 equals new student. This line creates an object of the student class. Let's understand each part. Student. This is the class name. S1. This is the object or reference variable. New. Creates a new object in memory. Student 0 calls the constructor and allocates memory. Assign student ID. S1.id equals 101. We are storing 101 in the object's ID variable. Now the object contains ID equals 101. Assign student name. S1.name equals Rahul. Now name equals Rahul. The student object now becomes ID equals 101. Name equals Rahul. Now call a method display. S1.display. Java goes inside the display method and executes. System.out.println ID. System.out.println name.
When we run a Java program, the statements are executed one by one inside the main method from top to bottom. Let's see what happens step by step. Step 1. Program starts. When you click the Run button, the Java Virtual Machine, or JVM, starts executing the program. The JVM first searches for the main method because it is the entry point of every Java application. Step 2. Enter the main method. The JVM enters the main method and begins executing each statement in order. Think of the main method as the starting point of your program. Step 3. Create the object. Java creates a new student object in memory. Memory is allocated in the heap. The reference variable S1 stores the address of that object. Step 4. Assign value to ID. Java stores 101 in the object's ID variable. Step 5. Assign value to name. Java stores Rahul in the object's name variable. Step 6. Call the display method. The object S1 calls its display method. Java jumps to the method definition. Step 7. Execute the display method. Java executes the first statement, system.out.print ID. Then Java executes system.out.print name. The output is 101, Rahul. Step 8. Program ends. After the display method finishes, control returns to the main method. Since there are no more statements to execute, the program terminates.
Thank you.